Understanding Polynomial Functions, a simple guide. Hello, everyone. Today, we're diving into the fascinating world of mathematics. Specifically, we're going to unravel the mysteries of polynomial functions. Whether you're a math enthusiast, a student tackling algebra, or simply curious about mathematical concepts, this video will shed light on what polynomial functions are, their characteristics, and why they're so important. Let's embark on this mathematical journey together. At its core, a polynomial function is a mathematical expression made up of variables, coefficients, and exponents, which are combined using addition, subtraction, and multiplication. The most general form of a polynomial function looks something like this. f(x) equals x caret n plus n1x caret n1 plus a 2x squared plus a 1x plus a0. Here, n, n1, a1, a0 are coefficients, which are just numbers. X is the variable, and n is the highest exponent in the function, which must be a whole number. The degree of the polynomial is determined by the highest exponent. For example, if the highest exponent is 3, it's a cubic polynomial. Polynomial functions can vary greatly depending on their degree. Here's a quick rundown. Linear polynomials, degree 1. The simplest form, looking like f(x) equals x plus b. It represents a straight line. Quadratic polynomials, degree 2. These take the form f(x) equals x squared plus bx plus c and represent parabolic curves. Cubic polynomials, degree 3, expressed as f(x) equals x cubed plus bx squared plus cx plus d, leading to more complex curves. Quartic polynomials, degree 4, and beyond introduce even more complexity into the graphs of these functions. Understanding the degree of a polynomial is crucial because it gives us insights into the function's graph shape and the number of roots it may have. Polynomial functions have several key characteristics that make them unique. Continuity. These functions are smooth and continuous, with no gaps or holes in their graphs. End behavior. The ends of the graph, as x approaches infinity or negative infinity, depend on the leading coefficient and the degree of the polynomial. Roots, zeros. Points where the function crosses the x-axis, corresponding to the solutions of the equation f(x) equals 0. Turning points. Points where the function changes direction, which are fewer than the degree of the polynomial. Understanding these characteristics helps in graphing polynomial functions and solving polynomial equations. Congratulations! You've taken a step into the world of polynomial functions. Remember, these mathematical expressions are not just abstract concepts. They have practical applications in physics, engineering, economics, and more. By understanding polynomial functions, you're unlocking the door to a deeper understanding of the mathematical principles that shape our world. Keep exploring, and never stop learning. Thanks for watching, and I hope this video has been helpful to you.